Okay, so we're talking about section 3.1, and in this section it's all about quadratic equations. So we're looking at quadratic functions and equations. So quadratic functions have the following characteristics. First of all, we're looking at the path of a projectile when we think about a quadratic, because whether it be a basketball being thrown, basketball going into from the shot, obviously from the shot, the person's shooting from, say, a lower location, and the ball's going this way, or if it's a football that you're throwing, and obviously, you know, with the spiral throw, the football's being thrown or kicked. Let's assume it's being kicked. You know, we're kicking this into the field goal, and it's got a parabolic shape to it, or destination to it. So any projectile, especially in sports relation, is an example of a quadratic function. So a quadratic function generally is, as I've stated in prior lessons, f of x is equal to ax squared plus bx plus c. And so we're also assuming that a is not 0. And in this case, we're assuming that b and c are real numbers. That's and, not plus. B and c are real numbers. So again, we relate to what we call a parabola, any object. So I'm drawing an x coordinate system here. So if we think of, say this is x is 4, and we're going to refer to that as the axis of symmetry. So the axis of symmetry is what you see here in the blue line. And this splits the parabola exactly in half. Obviously this picture is not very nice, but this is referred to as the axis of symmetry. So when we think of the axis of symmetry, I want you to remember the formula, negative b over 2a is equal to that x value, which we refer to as the axis of symmetry. Now you will notice in this case, this is a case where a is positive, and so that tells us that it faces up, and therefore the vertex, which is down here, this is the vertex, or the lowest point where it turns, in this case is referred to as a minimum point. All right. On the opposite continuum, and I'm just going to use the same axis or coordinate system. It doesn't mean anything. It just so happens I just use this. So let's estimate that this is the drawing. Once again, the axis of symmetry is here, cutting this parabola exactly in half. Parabola is the name of the shape. You've probably heard it. This is also a parabola. They're both parabolas. It's just that in this one, like I said, a is positive. In this one, a is negative. So when it's negative, it goes down. So in this case, the vertex is considered a maximum point. Okay, and again, the axis of symmetry is found by using the formula negative b over 2a is equal to that x. And that x by default is also the x value. So these are the same values of the vertex point. You could solve for the y by substituting in the x that you obtained from here into the equation to obtain the y value that you're missing for the actual vertex. All right. Let me see what else we're missing here. Let me also discuss with you what we refer to as the standard form. And we've been doing circles, so this should be clear. And so the standard form of a quadratic function so in this case, the standard form of a quadratic function should look as f of x is equal to some a value. If this is positive, it opens up. If it's negative, it opens down. And then x minus h squared plus k, where a is not equal to 0. All right, and so that is in standard form. So let me show you, or let me discuss with you other functions or other rules. So first of all, when we graph these, there are some rules we stick to. So as we graph this, you need to remember that if a is greater than 0, meaning that it's positive, the actual parabola opens up. And if a is less than 0, then our value is negative, and therefore the parabola opens down. And so in this case, it goes up. In this case, it goes down. In terms of the shape. Number 2, we want to determine the actual vertex, the hk value. Determine if it's a minimum or maximum, which you determine here. Here, the hk in, let's call this I. In I, this is considered a minimum. The vertex is a minimum. In double I, so we would say in this case, the hk in double I, meaning the second little example, the vertex is a max. Okay. So the third thing you want to do is locate any intercepts. And you begin by setting x to 0. So you would start with f of x equal to 0, that's one, and the other is if you determine the x-intercepts. So you also, in number 4, want to determine f of 0 equals what? And the fifth point that they state when you graph these is basically that you want to plot each of these points. So just start plotting the intercepts, the vertex, etc. Okay? So you plot your points. And so that's what we're going to do in this first example here. And so I'm going to start with example 1. In example 1, we're going to graph the parabola where we have f of x is equal to negative 2 times x minus 3 squared plus 8. So let's begin with our points. We start with point number 1. Which way does it open? So that our a value is negative. It's less than 0. Therefore negative. In fact, it's negative 2, right? You can see it right here. So we know that our parabola opens down, frowny face. So in point number 2, we find the vertex. Our vertex in this case, if we know that in this case h is equal to positive 3, and you see that in this location right here, since it's negative 3, remember it's inside with the x, so it's a hypocrite. So it's 3, and our k value is equal to positive 8. Remember, this stays true to itself. So our vertex, in fact, in this case, is 3, 8. In step 3, Find the x-intercepts. So x-intercepts in this case, so we would say then f of x is equal to 0. And so that means that we would set our equation to 0, and that equals -2 parentheses x minus 3 squared plus 8. All right, and so doing a little math, the first thing we're going to want to do is let's bring everything that's on this side of the equation over here. So you end up with 2, because I'm going to add this. I'm going to go plus 2 parentheses x minus 3 squared and bring it over here as 2x minus 3 squared. So 2 parentheses x minus 3 squared is equal to 8. And now we're going to solve by dividing by 2 on both sides. And that'll cancel. That leaves you x minus 3 squared is equal to 4. All right. And so I will take now the square root of both sides. So I'll take the square root of this side and this side. And that's going to give me x minus 3 equal to plus or minus square root of 4. So in this case, your answers are going to be twofold. So x minus 3 equals 2, and you have x minus 3 is equal to -2. So x is equal to 5 on this side, and x is equal to 1. Okay? And so those are our x-intercepts. All right, step 4 in our question. Now we're going to find the y-intercepts. So in this case, we're going to say f of 0 is equal to -2 parentheses 0 minus 3 squared plus 8. And that equals, as we continue the math, this will give us -2 parentheses -3 squared plus 8, which leaves us -10. So our y-intercept is, in other words, when x is 0, y is -10. In these two cases, our intercepts are 5, 0, and over here 1, 0. These are the x-intercepts. All right, and this is your y-intercept. Now we graph. So when we graph this particular parabola, so again, I would use Desmos to get a nice drawing, but I'm just going to show you a rough graph of what you should be doing. And so in our case, we're going to begin with our axis of symmetry and our vertex. So the axis of symmetry is, according to this, 3. And so at x is 3, I know that this diagram is symmetrical. This is the middle, in a sense. I know that I have 2 x-intercepts. So consider these 2 x-intercepts. I know that this goes through -10. Let me see if I can clean this up a little bit. I'm going to need a little bit more room here, so I'll draw this a little lower. All right, so let's assume -10 is down here. So this would be 0, -10. Okay, and so if it's equidistant, notice that from here to here, I've got a 3-unit jump. So another 3-unit jump would be somewhere about the 6. So if I parallel these, this would be my other point, which would be, in this case, let's go with -10, 6, or 6, -10, right? And you just count it out on the graph. Lastly, the vertex, which is 3, 8. So that, again, I have to stretch this up a little bit based on the scale I'm using. So let's assume y is 8 here. So this is 3, 8. So here is my vertex. That's the point 3, 8. And that's my high point. And I know it's my maximum because it's a -2 in front of here. So now you just sort of connect the values and you have a rough graph of what your parabola should look like. If I show you this on Desmos, you'll see it a little bit more clearly. So let me do that. Go to Desmos. All right. All right, so if I'm looking at Desmos, I'm going to go ahead and I'm going to input y equals, parentheses, -2, actually y equals -2, parentheses, x minus 3 squared plus 8. And there's your parabola once again. Again, look at the numbers. If you look carefully, that vertex is that value, 3, 8. Here is your other cutoff, 1, 0. There's the other one, 5, 0. Those are your x-axes. You also have this -10 down here, 0, -10. So if you recall, I said that this was 6, 10. So if you punch in here, you see how you have 6, -10? All right, and that's how you know. And our y, well, in this case, x equals 0, x equals 3. Well, x equals 3 is your axis of symmetry. Okay? So you might want to use Desmos as a particular point for help on determining, you know, where these points are sitting. It just will help you to locate them with a little more ease, I think. Okay. So what I would like for you to try now, following this example, and I'll stop this for you so you can practice. I want you to try and graph f of x is equal to negative of x minus 1 squared plus 4. All right, and I'll go ahead and pause this for a few minutes. And then you can continue as we review this. Okay, so go ahead and hit pause, and if you're watching this on your own, and graph that and move through that question. So if I start reviewing this, at this point you've turned this video back on. What you're going to want to do is start with step 1 and determine, does it open up or down? Obviously this opens down. This is a parabola that has this shape, and you know that because a is less than 0, therefore negative. All right, step 2, we're going to find the vertex. Well, to find a vertex, I'm going to look at this number and this number. Based on that information, I have 1, 4 as my vertex in this case. Okay. Notice that the x value is always the opposite sign of what it dictates. Point number 3, I'm going to set the equation to 0. So 0 is equal to the negative of x minus 1 squared plus 4. And so in usual fashion, what we're going to do is we're going to add the x minus 1 squared and move it over here. So now we have x minus 1 squared is equal to 4, right? So if I bring this down, x minus 1 squared, this is equal to positive 4 because all of that canceled on that side. Again, if I take the square root of both sides, I end up with x minus 1 is equal to plus or minus 4, square root of 4. All right, and so in doing so, I end up with x minus 1 is equal to 2, and x minus 1 is equal to negative 2, which means that either x is equal to 3 or x is equal to, if I add the 1, so negative 1. So that means that I have an x-intercept 3, 0, and the other x-intercept is negative 1, 0. Step number 4. In step number 4, I'm going to look for the y-intercept. So these again are our x-intercepts. The y-intercepts, in this case, are going to be where I set all x values to 0. And so in this case, f of 0 is equal to 0 plus 3 squared. I'm sorry, I'm doing the wrong question. So we're doing the negative of x minus 1 squared plus 4. So if that's 0, then I have y is equal to 0 minus 1 squared plus 4. So this gives me 1 squared, which is 1 plus 4. So therefore, 1x is 0, y is 5. All right, and the last part, we want to graph, which is number 5. Now we're going to graph. Okay, and we'll check our points. And what you would want to do is plot what you do have. Okay, so we do have a vertex, which we said the vertex in our case, I'm going to see if I could do this on the side. I'm actually going to do the drawing here. So according to this, it faces down at 1, positive 4. That should be my vertex. I have an x-intercept at 3, 0. Another one at negative 1, 0, which makes sense. I have, according to this, a y-intercept of 0, 5. Let's see why that is at 0, 5. Because 0, 5 would be up here. That doesn't make sense. Oh, negative 1, I'm sorry, at 0, 3. So this is incorrect. Because this is a negative 1. So it's negative 1 plus 4. So it's actually 3, not 5. And you can tell based on how the diagram is going to look. So at 0, 3, I'm crossing here. So this is going as such and as such. And so basically that's how you graph a parabola using the 5-step process, right? And you could check with Desmos as well. All right, example 2. And we're still graphing. We're going to graph. We have f of x is equal to x plus 3 squared plus 1. And so in this case, we're going to do the same thing. Same 5 steps. What's going to happen in this one is you may end up with imaginary numbers. And the gist of this one is just that, is that it will not have x-intercepts. So let's look at it by going step by step. So in step 1, the a value is positive because it is greater than 0. So it opens up. And you can see that right in front of here. There's nothing, it's just a plus. Step 2, we're going to find the vertex. And so to do that, remember the x value here is always the opposite sign. So this will be negative 3, 1. Okay, for step 3, we're going to solve for f of x is equal to 0. And so in that case, 0 is equal to x plus 3 squared plus 1. So first step is going to be, I'm going to subtract 1 on both sides. And in doing so, this gives me negative 1 is equal to the square, well actually, let me not skip that step. So x plus 3 squared. I'll take the square root of both sides, right, to solve. So square root of negative 1, square root of all of this. So now I have x plus 3, I reversed them. X plus 3 is equal to square root of negative 1. And it is also equivalent to the negative square root of negative 1. Because remember, it's always plus or minus the root, right? Because plus or minus. And so if I solve for either side, remember that the square root of negative 1 is equal to x, or I. And so in this case, I have negative I. And in this case, I have positive I. All right, and so if I'm solving for x, thinking of this in terms of x plus 3 equal to this, so I'll subtract the 3 on this side and on this side. So my two answers are negative 3 plus I and negative 3 minus I. All right, and so those are imaginary, so there are no x-axis, no x-intercepts, no x-axis intercepts. For step 4, what I want to do in that case is x is going to be 0, so f of 0 is equal to 0 plus 3 squared plus 1 equal to, let's see, this will become 3 squared is 9, so 3 squared plus 1, which is 10. And so this definitely goes through the point 0, 10. And so to graph this drawing, the fifth point or step, so if I graph this, I'm going to draw the coordinate plane. I could tell that it's going to be in the second quadrant, so I can save myself a little space. At 1, 3, which is our vertex, and we also know that this goes through 0, 10, so let's pretend that's up here. Just remember, it's equidistant, so the axis of symmetry is where x is negative 3, right? So that means that I'm 3 points or 3 jumps, 1, 2, 3 from here, so 1, 2, 3 from here. So think about it, this would be negative 4, negative 5, negative 6. So at negative 5, at negative 6, equivalent to 10, so this would be the point negative 6, comma 10, and this is our point 0, comma 10. And obviously this is our axis, so this is going like this, and it goes through there as well. Okay? And again, you can check it with technology, use Desmos. All right, and so that's example 2. I'm going to give you a try here. You just pause the video if you need to. And this is f of x is equal to x minus 2 squared plus 1. So go ahead and try that one. Pause the video. I'll pause during class so you can go ahead and graph it and we can discuss it. All right, so we're going to look at example 3 now. In example 3, we are graphing a quadratic. We're graphing a quadratic in the form where f of x is equal to ax squared plus bx plus c. And so they're going to give us f of x is equal to negative x squared minus 2x plus 1. And we're also going to identify the domain and the range of the function. All right, so using this, we're going to start with, again, point number 1. The parabola opens down. We know that because a is less than 0, meaning that a is negative. We can see that right here. All right, and we're also going to, in part 2, we need to find that vertex value. And so since we know that we're going to use where x is equal to negative b over 2a, and the f of negative b over 2a is our value for y. Okay, so we're locating both of these parts of the equation. Give me 1 second. Let's pause this recording. Okay, so in question number 2, we're going to use our equation. Remember, the negative b is sitting right here. That's your negative b right here. So that happens to be a negative 2, so I'm glad, because this is negative b. See how the 2 is with the negative? All over 2a, so 2 times, and a happens to be negative 1. So this gives you positive 2 over negative 2, and therefore this is negative 1, which is equal to the x value in the vertex. So to find the y value, I'm going to say, okay, then negative 1 squared minus 2 times negative 1 plus 1 is equal to that y value for the vertex. This is solving for the vertex. Okay, and so once we do that, we plug it in, we end up with, this will become negative 1 plus 2 plus 1, which is equal to 2. So that means that our vertex is negative 1 comma 2. All right. Then we solve for the x-intercepts. That's the second thing we're going to do, or the third thing we're going to do. So for number 3 in our steps, we're going to say in that case, f of x is equal to 0. And so therefore 0 is equal to negative x squared minus 2x plus 1. You're going to consider in this case that we're going to have to use the quadratic formula, because we don't really know what this what to do with that negative. So we're going to say minus 2 plus or minus the square root of negative 2 squared minus 4 times negative 1, which is a, times b, which is 1. So this will result in 2 plus or minus the square root of 4 minus 4. And all of this is over negative 2. I forgot to do that part. Remember, this is 2a, so 2 times negative 1. All right, so this leaves us with, this becomes 16. Or I'm sorry, this becomes 4 plus 4, so square root of 4 plus 4 is square root of 8. So we have x is equal to 2 plus square root of 8 over negative 2, or we have 2 minus square root of 8 over negative 2. In terms of their decimal equivalent, this is approximately 2.4, and this is approximately 0.4. and those are the two values for x. So that means that we have an x-intercept at negative 2.4 comma 0, and we have another x-intercept at 0.4 comma 0. Okay. In step 4, again, this is the same step, nothing's changed. Now we want f of 0, which is equal to negative 0 squared minus 2 times 0 plus 1 equals 1. And so our y-intercept is 0 comma 1. And now we graph. Now on your test or quiz, well, quizzes sometimes, if they ask us, usually that happens face to face. They'll actually have you go through the steps as I'm physically doing them on the screen. But however, chances are if it's a test, it's usually multiple choice, because it's kind of a hassle to be grading these. They're kind of tough to grade. And so just keep that in mind. Okay, so our diagram, the majority of it is going to be below the x-axis. So at negative 2, 1, or negative x is negative 1, that's our axis of symmetry. And at 2, we have the vertex. Between negative 2 and negative 3, so here's negative 2, negative 3, and this is negative 1. Terrible spacing. Let me stretch that out just a little bit, because that's going to get crazy. All right, and so what I'm going to do is I'm going to give a little space here. All right, so here's negative 3, here's negative 2, obviously this is negative 1. So our graph is, like I said, it was negative 2.4, so let's say that's about there. And the other piece was 0.4, which is just about there, assuming this would be 1, okay? All right, so those are the two intercepts, and we know that it also goes through here. And so our graph is behaving as such, and that'll give us a rough estimate of what the graph looks like. Now for the domain, you can see that the domain is all x values, because there's no restriction going left to right, even though all we see is a snap shot of this, but this stretches out infinitely, so it keeps going, opening up in a sense this way and this way. There's no restriction. However, so the domain, just to finish this real quick, is from negative infinity to positive infinity. Okay, so I need you to always take a secondary look at it, not just from the snap perspective that we have, where we're limited from our graph. Obviously we can't draw forever, but as this opens up this way. Okay, now the range, remember the range comes from the bottom up. You read the range this way, right? And so in this case we're coming from negative infinity up to 2 inclusive, and we stop there because there's nothing else beyond this point. Okay, so if you want to try one, I'm going to give you a few minutes, pause the video, try this. In this case we're going to graph f of x is equal to negative x squared plus 4x plus 1, and then identify, and when I say graph, I mean use steps 1 to 5, which once you graph, identify the domain and range of the function. All right. All right, take a few minutes, go ahead and do that. And I'm going to pause the video here, and we'll consider this part 1.